So let's talk about continuity at an endpoint. Um, there's a kind of a different definition for continuity at an endpoint, and really all it is saying is that if it's like a right side endpoint, as you approach from the left side, do you approach a value, and if you plug it in, do you get that value? So pretty much, is this hole filled in or not? So the question here is f of x continuous at x equals 2, and the answer is yes because we have a filled in hole. So this would be yes. This is by definition for an endpoint continuity, or being continuous at an endpoint. If you had something like that, 1, 2, or if you had something like that, whoops, the other way around, a hole and then it's filled in somewhere else, 1, 2, then this would not be continuous at an endpoint, because as you approach from the left side, you get a limit, that's whatever this y value is, but when you actually evaluate, so it's like half of the continuity definition. If the limit, let's say limit as x approaches some a value from the left side, we've been doing left side, of f of x equals L, and f of a equals L. That, I mean, it's just half of the definition. So to be continuous, this has to be satisfied. That's for things that are on the right, like right endpoints. If it was a left endpoint, then it would just be that, because you approach from the right side to get to that endpoint. Hopefully that makes sense. It's not terribly complicated, but that's just continuous or continuity at an endpoint. If it's filled in, then yes, it's continuous. If it's not filled in, then no, it's discontinuous. So if you had an asymptote, then you just say, okay, well, we already know 1, 2, something like that. We already know that, yeah, we're not going to be continuous at x equals 2, just because you never get there. It's not filled in at all. But it's continuous at x is less than 2. Any value less than 2, yes. Less than or equal to, no. Just because you can't have the stuff at the asymptote. So hopefully that makes sense. I'm done with this one.